This research into coordinated fire attack in single-family dwellings built upon previous FSRI-led studies that examined the standalone tactics of ventilation and suppression on the fire ground. We conducted 20 experiments in 8 different structures to analyze the coordination of suppression and ventilation tactics in single-family dwelling fires. 14 of the experiments allowed examination of second-floor bedroom fires, while the remaining 6 involved first-floor kitchen fires. Suppression tactics included interior fire control and exterior fire control, followed by interior extinguishment. Ventilation tactics included horizontal, vertical, positive pressure, and hydraulic ventilation. These experiments provided a deeper understanding of how to best pair suppression and ventilation tactics for a coordinated attack. Although differences between the structures and environmental conditions among the experiments limited the ability to make definitive, direct comparisons of tactic performance, several trends were identified that could influence the tactical decisions on the fire ground. No meaningful increase in temperature outside the fire room was observed when ventilation tactics were executed in coordination with the onset of suppression. After suppression has begun, ventilation tactics should be focused on establishing airflow through all areas in the structure where occupants may be located. The most effective means to accomplish this, in many scenarios, may be the coordinated horizontal ventilation of as many windows as necessary. Less than 250 gallons of water were used during the initial knockdown of the fire, and less than 500 gallons were used in total, including suppression and overhaul, during each of the 20 room and contents fire experiments. Regrowth was observed during the 1-minute delay following exterior suppression in second-floor bedroom fires, when no additional fuel wetting was performed. On the contrary, regrowth was not observed in the 1-minute delay following exterior suppression on first-floor kitchen fires, where more complete wetting of the room contents was possible. Opening the front door is ventilation. Even in experiments where the fire room windows and front door were the only sources of ventilation, fire growth was observed because of the more efficient flow path created from front door ventilation. Additionally, the air entrained through the open front door improved conditions for potential occupants located in the flow path. It is important to note that the appropriateness of ventilation and suppression tactics ultimately depends on local resources and the circumstances of the specific incident. The 20 experiments analyzed in this report provide a foundation for understanding the impact of different means for coordinating suppression and ventilation on a residential structure fire ground. This research explored how coordinated suppression and ventilation affect fire dynamics and exposures to occupants and fire service personnel. Future research should further quantify occupants' thermal and toxic exposure above the fire floor compared to occupants located on the fire floor under a broader range of initial conditions and fire department tactics. While the exterior fire control experiments provided insight into water application tactics in the presence of ceiling failure, additional research to quantify water dispersion for various construction configurations is needed. Additionally, the effect on fire dynamics and toxic exposures resulting from the failed ceilings should be further quantified. Additional research is needed to address the limitations of this study and address the needs of the fire safety community. This includes developing a skin burn assessment package that accounts for blood flow, sweating, and so on. Additional research on heat transfer into and through personal protective equipment, and more work to understand the coupling of suppression and ventilation tactics with search and rescue. This project was supported by the U.S. Department of Homeland Security and Federal Emergency Management Agency's Assistance to Firefighters Grants Program.